Welcome to another edition of ProSoft Technology video training. Today we'll be covering the process for a first-time setup and configuration for the PLX51 DL232 data logger. The DL232 is designed to help users get a comprehensive view of any issues in equipment before heading on site to troubleshoot. By seeing performance history, the true nature of problems can be determined and the time needed to diagnose an issue is greatly reduced. Today we'll be covering the general setup for the PLX51 and then we'll cover how to set up the module to log tags from a Modbus TCP IP device, which is gathering data from a water tank application. I have a tag that displays the current water level in the tank, an alert that the tank is nearly full, and a tag that lets me know if the pump for the tank is on or off. We'll cover downloading and installing ProSoft PLX50 configuration utility software, creating a new project for our module, configure the PLX51 to log tags from a Modbus TCP IP server, and we'll view the log data and save it to a CSV file. Let's begin. The first thing that we need to do is download and install the ProSoft PLX50 configuration utility software from the ProSoft Technology website. This is a free application that's used to configure the PLX51 DL232 module and will allow you to do all the necessary configurations and mapping to make the module an integral and useful part of your program. Once we have the files downloaded, go ahead and install the PLX50 configuration utility to your PC by following the prompts. When it's done, we'll open up the configuration utility and open a new project. The first time you connect the PLX51 to your network, you'll need to launch the DHCP server and assign it an IP address on your subnet. If you're going to connect to a network with its own DHCP server, you should disconnect from that network until we get the IP assigned. So just click the button in the menu bar, and here's our gateway. It'll say ProSoft Technology under Vendor. Click Assign, and on the window that opens, I'll enter in an IP address that I know is available on the local network. Then select Enable Static and click OK. The bar should turn green, letting you know that the gateway has been assigned the IP address and is now connected. We can close this window. Next, right-click on the New Project under Project Explorer and select Add. And on the Add New Device window, select DL232 Data Logger. We then come to the main configuration window, and you can see that we have 5 tabs at the top. The General and Serial tabs encompass the basic configuration for the gateway, and the other tabs will only be enabled depending on what data source you select. On the General tab, you give the gateway an instance name and a description if you like. You then enter the IP address, and this is the address that you will use to access the gateway. You can either type the IP address in manually, or you can click the Browse button to the right of the field to bring up the target browser, where you can see all the devices on your network and just select your PLX51 module. Next, we come to the Data Source Selector. From the drop-down menu, we can select what sort of device we want to log data from: a Logix controller, a DF1 device, and a Modbus RTU or TCP IP device. For this training session, I'm going to log data from a Modbus TCP IP device, so I'll select Modbus TCP IP. We also have 2 logging modes, hold and overwrite. You're basically selecting what you want the PLX51 to do in the event that its database of more than 16,700,000 tags fills up. Hold tells it to stop logging new data and just hold on to what it has logged up to that point. Overwrite will instruct it to go back and begin overwriting the oldest log data with new data. It depends on how you plan on using the PLX51. I'll select Hold. Moving on, we'll click on the Serial tab where we configure the serial port. Obviously, this only needs to be configured if you'll be logging data for the DF1 and Modbus RTU sources. At the top, we have the basic serial network configuration settings, and below there's a section specifically for DF1 network settings. We won't be doing any configuring here, but we have another video for the PLX51 router that addresses this section in more detail. The logic source and DF1 source tabs are for logging data from those respective devices. We have another video where we cover logging data from a control logics processor. We'll move on to the Modbus source tab, and this is where we will identify the Modbus devices that we want to log data from. We can log tags from up to 3 different devices at a time, and we will also specify the register addresses from those Modbus devices that we want to log. So under Modbus devices, we'll select the Modbus device that you want to connect to. In my case, it's a Modbus server, gathering data from a water tank. We'll enter the IP address of the device and select its node address. If we were connecting to a Modbus RTU device, it would just be the node address. We'll also give it a name that will help us identify it. And if you have more than one device you want to map, you can go ahead and add 2 more. At the bottom, under Modbus tag, you specify the data files in the server that you want to log into the PLX51 database. There's no browsing feature here, so we'll have to manually select the device from the list at the top, and then enter a tag name. This can be anything that you want, but it should be something that would help you identify what the data represents. Be sure not to use spaces in your name here, or else it won't be valid and you won't be able to download your configuration. The tag ID is just a number associated with a particular tag. We'll select what type of function that we need to use for this data. My current level tag will contain a 16-bit integer that will be under holding registers, and the level warning and pump status are both coils. Next, we enter the register address for each tag. This is where the data is being placed in the server device. For me, it will be address 40,011 under holding registers and address 3 and 4 under coils. Now the PLX51 uses 0-based addressing, so Modbus address 40,011 would correspond to address 10 for my tank level, and it would be address 2 and 3 for my binary data. Next, we identify the data type that we'll be logging, and it will be an integer for the level and a bool for the other 2. And from here, we have some options to define how often and under what conditions we want to log values from each of the tags here. Over on the right, we have the 3 parameters to configure for when data should be logged. The first 2, delta Y and minimum time, work together to ensure that tags are logged with the frequency that you want. The last one is maximum time between logs, and we'll get to that one in just a little bit. The delta Y is a simple value change. So if we leave it at 1, anytime the value for this tag changes by 1, up or down, it will trigger a log on that tag. But it will wait for the minimum time interval between logs to elapse before it actually logs the tag. If the variable that you're monitoring is something that changes rarely, or if it's a binary, you might just leave it at 1. But if it's something that changes often or is more volatile, you might want to increase it to 10 or 100 or whatever would be appropriate for your application so that you log data in meaningful chunks. Under minimum time, the time units are in seconds. So if you set this to the minimum of 50 milliseconds between logs, you could log data for a tag 20 times every second by entering a 0 for delta Y. This will remove any value change requirement to trigger log, and the module will just log data at whatever frequency you enter here. Unless you're monitoring something where every little change is critical, you really don't want to do that. Keep in mind that while our capacity of 16.777 million tags sounds like plenty of room, it can fill up pretty fast if you have a lot of tags that you're logging frequently. We can log data from up to 200 tags simultaneously. And if we logged all of those tags just once every second, you would completely fill up the database in less than a day. So it's good to be a little conservative when setting the value change and minimum time interval. For my application, I have a 500-gallon tank. I really don't need to track every gallon in or out, so I'll set the value change to 5 and the minimum time to 5 seconds. My other tags are binary, so I'll leave them at 1 and 1 since I would like to log any change that might occur. The final parameter here is the maximum time between logs. By default, we have it set to 3600 seconds or 1 hour, at which time it will log the data for the tag even if nothing is changed. Again, you can configure this to log data with the frequency that you think you'll need for the variables that you're monitoring. For my tank level, I'll set a maximum time of 600 to log the value every 10 minutes. And for the other two, I'll just leave it at 3600 since I don't anticipate them changing very often. Over on the left, we have the group member and trigger fields. And this is a way of connecting multiple tags together. So if one tag value is logged, it will automatically log data for one or more other tags as well. So in my example, I have a tank level reading. I have an overfill warning that will flip on when the tank is nearing full capacity. And I also have a pump status tag that lets me know when the pump that fills the tank turns on or off. I can use the frequency and timing features to set up when to log data for each of these tags independently, but I can also use the group features to ensure all the data that I might need gets logged at the right time. I'd like to ensure that I always have a reading of the tank level anytime the overfill warning turns on or when the pump turns on or off. Now what I can do is assign the overfill warning to group trigger A and the pump status to group trigger B. Then I'll make the tank level tag a group member for A and B. So now anytime the pump turns on or off, it will trigger a log for all members of group B. Likewise, anytime the warning is tripped, it will trigger a log for all members of group A. The tank level is a member of both of these groups, so either event will trigger a log for that tag, but it's only a member. It's not a trigger itself. So whenever the tank level logs in accordance with the parameters here, it won't trigger a log for the pump or the warning. The software supports up to 8 different groups, so you can get pretty fancy linking different variables and events together should you choose. Once everything is set up to your satisfaction, click Apply to save the configuration settings. And while you're at it, you should probably save your project at this point. We can now download our configuration to the PLX51. Just right-click on the data logger over in the Project Explorer window and select Download. Once the download completes, you'll automatically go online and begin logging data. As you can see, we have several new entries that appear in the Explorer view. Double-click on Status, and a new window opens. We have many tabs that show all sorts of data about what the PLX51 is up to. The Tag Status tab will show a live stream of the data readings of your tags as they are being logged. And the Recent Records tab shows a list of the last 8 logs. It will refresh as newer logs come in. And finally, we have the Record Management tab, where we have options of what to do with all the log data. And we can upload all log data to a CSV file, only the unread data, or we can actually erase the stored data. If we choose to upload, the resulting file will display the logs like this. And that should do it. If all the configuration information was entered properly, your PLX51 DL232 data logger should be logging the selected tags from your Logix processor. If you have any questions or would like more information about the PLX51 DL232 data logger, use the link in the description to go to its product page, or feel free to give us a call. Happy training!